Okay, today's lesson is on compound inequalities, which addresses standards ARAI 3 and ACED 1. And the objective is to solve and graph inequalities that contain the words and to solve inequalities that contain the word or. And before we get into this, I want you to stop and think for just a second. If I told you that for Christmas you could have a PlayStation and a game, then that would imply that I'm going to buy you both, right? You can understand that and means both things are happening. You're getting the PlayStation and you're getting the game, or the Xbox and the game. I already forgot what I said. But if I said, now for Christmas, you can either get a PlayStation or an Xbox. That means you're getting one or the other. You're not getting both of them. So kind of think about that as we're talking about this. The same concept applies with inequalities. When we use the word and, that means that two things can be happening at the same time. It's this and this is happening. If we use the word or, we're saying, okay, you can either be on this side or you can have solutions on this side. So we'll look at what that means. Compound inequalities consist of two distinct inequalities, and they can be joined by the word and or the word or. So take W is greater than or equal to 25 and W is less than or equal to 50. We can rewrite this as W is in between 25 and 50. It's greater than or equal to 25 and it's less than or equal to 50. But the way that we would read this is 25 is less than or equal to W, which is less than or equal to 50. Or we could write it as 50 is greater than or equal to W, which is greater than or equal to 25. Notice that in each, both of the inequality symbols are facing the exact same direction. So this can be interpreted as W falls somewhere in between 25 and 50 inclusively. And when I say the word inclusive, it kind of sounds like include, right? Inclusive, include. And that's because we can include 25 and 50 in that. That means it could be, because of the equal sign, it could be 25 and it could also be 50. So we want to make sure to include them, which is where the word inclusively comes from. So let's look at an example here. I've got 2x plus 3 is greater than 2 and 5x is less than 10. So since there's the word and in there, we know that both things are happening at the same time. My value of x falls into both of those categories. So we call this a conjunction. So you have to solve each part of the inequality, and then we're going to graph the solution, which is going to be the intersection. It's where the lines cross. Both conditions of the inequalities must be met. So we're looking for an overlap so that they both happen at the same time. So let me see if no. Okay, so we've got the 2x plus 3 is greater than 2. And we've got the 5x is less than 10. Let me paste this in here. So we've got some room to work. Okay, I want to solve the 2x plus 3 is greater than 2 to begin with. I'm going to go ahead and subtract 3 from both sides of my inequality. I want to get rid of it, so I've got a positive 3. To get rid of it, I subtract 3. Whatever I do to one side, I got to do to the other. So 2 take away 3 is negative 1. At this point, I'm going to divide both sides by 2. So x is greater than negative 1/2. Then I've also got this other part that has to be true, this and part. And it says 5x is less than 10. So I'm going to divide both sides by 5, and I get x is less than 2. So this says x is greater than a negative 1/2, and x is less than 2. So that means somewhere on my number line, or my values of x are somewhere in between negative 1/2 and 2. And this is not inclusive, because there's no equal to, so we're not including. So we got the negative 1/2 right here, open circle. We've got the 2, open circle. And think about what we're looking for. This says all the x's greater than negative 1/2, so that's this line. This says all the values of x that are less than 2. So that's here. So what numbers could be both at the same time? And we know that it's everything that's happening right in here. Everything in between -1 and a +2, because that meets both of these inequalities. So back to all of these words over here. What this was saying is we're looking for the intersection of the two inequalities, where both conditions are met, and only the values in between here meet the conditions of this side of the inequality and the conditions of this inequality. Okay, so interval notation. We talked about set builder using x such that x is less than 2, or we use the fancy notation x such that, let's just go with this one up here, such that 2 is less than or equal to x, which is less than 6. This is the set builder that you're familiar with. But at this point in the game, we are going to learn about interval notation. It's important to know both, because you will see both over and over again in math. Interval notation is a connected subset of numbers. And interval notation is an alternate to expressing your answer as it's an alternative to expressing your answer as an inequality. So what we're talking about here is this set of parentheses. Like, let's just use this one for example. Anytime we have a not included, no equal to, then we are going to use the open parenthesis. So we're going to look at this one. Oops, I cloned it. I meant to delete it. Sorry. We're going to use the open parenthesis on the side where we're not including x. And let's think about what the graph of this would look like. We want x's that are greater than or equal to 2 and less than 6. So this one would go out that way. Less than 6, it goes out that way. So we know that this is an overlap in between here. So if we want to write this using interval notation, I always start at the left, write my left number first. The bracket shows that I'm including it, which is right here. The bracket means included or closed. It's a closed circle. So we've got bracket 2. And then on my graph, it stretches all the way up here to 6. So I put comma 6. And the parenthesis shows that I am not including 6. So this is my set builder notation. This is my interval notation. And this is just graphing it, looking at it graphically. So there's 3 different ways to express the exact same thing. So here's, you might want to pause the video and write this down. I'm not going to spend a whole lot of time on it. But notice open circles on both ends. So we have parentheses on both ends. Closed circles, so we've got brackets on both ends. An open and a close, so a parenthesis and a bracket. And here, this is showing that it goes on forever in this direction, which means it's going towards positive infinity. And you cannot ever include positive infinity because positive infinity isn't an exact number. It's just saying it goes on and on and on forever. So anytime that you have a parenthesis, or infinity, you must always use parenthesis to show that it's not included. And on this one, it's going from negative infinity. We always read left to right, so it's pointing forever down here in this direction. So we start at negative infinity and we come up to 5, and the bracket shows that I'm including 5. Okay, so we're going to write a compound inequality to represent this and to graph it. And I personally like to go in order from least to greatest, but you don't have to do that. -4, x, and 10. Okay, this is an and problem, so we know we can include them all in one big set here. But let's look at this. The mouth is open towards the 10, so we want to keep it open towards the 10. Here my mouth is open towards the x, so I want to keep it open towards the x. And notice if they both end up going the same way. If they don't go the same way, then we've done something wrong. So back to here. If I want to graph x is less than 10, I'm going to put an open circle, and I'm going to come over here. If I want to graph x is greater than or equal to -4, closed circle to show that it's including negative 4, and everything greater than. So what are the solutions then to this compound inequality? Well, we know it's everything in between here. So if I'm writing it in interval notation, we're going to start at the left, always, and I'm including 4, so I use a bracket, and I'm going up to 10, not including 10, so I use parenthesis. And if I wanted to write it in not interval, but set builder, I would say x such that negative 4 is less than or equal to x, which is less than 10. Okay, so what compound inequality represents the phrase all real numbers that are greater than negative 1, all real numbers greater than negative 1, and all real numbers less than 6. Okay, so all real numbers greater than negative 1 and less than 6. So once again, I'm going to start off. I'm going to go ahead and graph this x is less than 6. All the values of x that are smaller than 6. Let's go ahead and graph all of my values of x that are greater than negative 1. And what is the solution of both? Everything in between here. So if I want to write that solution of everything in between, we know that we're going to start at negative 1, not including. We go up to 6, not including 6. So we should have a parenthesis. Okay, if I wanted to put it in set builder notation, I got x such that x is between negative 1 and 6. And we'll look back up here. X is greater than negative 1, so that means negative 1 is less than x. The mouth was open towards the x, the mouth is open towards the x. X is less than 6, x is less than 6. And both of these are pointing in the same direction. Okay, so and statements can always be written two different ways. We can always put them together as one big problem, or we can separate them as two problems. We've got all of this it says that 8 is less than all of this, and then it also says that 14 is bigger than all of that. So now we've got to write the solution in interval notation and graph it. So let's pull this out of here so we're not confusing ourselves. Okay, so we have that 2 is less than m, and m is less than 8. So we're going to put it in interval notation and graph it. I like to graph it first. We want the m's that are greater than 2. So start at 2, open circle, it's not including 2. We want the m's that are less than 8, open circle, not including. We know it's everything in between. It's everything in that overlap there. So when I write out my interval notation, I start at 2 and I come up to 8, and I'm not including either one. If I put it in set builder, I want to have x such that, I guess I should probably use m, huh? So we could say m such that m is between 2 and 8. So 2 and 8. We know m is greater than 2 and m is less than 8. And there's my set builder notation. Okay, so let's look at this one. This sometimes gets a little bit confusing when it's written all as one. I have students that don't remember to break it apart. So I'm just going to go ahead and take it out chunk by chunk. We've got negative 3 is less than m or equal to minus 4. So that's that part. And I know I need the word and in between here because it's all pushed together. And then we've got this other piece here. The m minus 4 is less than negative 1. Okay, so we can go ahead and start solving. I'm going to add 4 to both sides. Get rid of it because negative 4 plus 4 is 0. Now I have this m by itself. Negative 1 plus 4 is 3. And then over here, on the flip side of things, I have to add 4 to both sides. Same process. Negative 4 plus 4 is 0, so now I've got m by itself. Awesome. Negative 3 plus 4 is 1. So we know our value of m falls between 1 and 3. And we can look at this on the number line. So 1, 2, 3, 4, and 0. So if I want to graph the red part, we're going to look at the values of m that are larger than or equal to 1. So we know we want to include 1. I always like to flip-flop it because it just, I don't know, makes more sense to me, but you don't have to do that to show that m is greater than or equal to 1. On this side over here, we've got m is less than and not including 3. So what numbers are bigger than or equal to 1 and less than 3? Well, we know that's the numbers right here in the overlap. So it starts at 1, including 1, and it goes up to 3, not including 3. If I put that in set builder, we would say x such that x is between 1 and 3. It's less than 3, and it is, got the less than or equal to right here. 1 is less than or equal to x, which is less than 3. And there it is. Interval notation, set builder notation. Okay, go ahead and pause the video and try this problem. I'll read it to you real quick. But to earn a B in my class, you need between an 86 and a 90 inclusively. So you can have an 86 and it be a B, or you can have a 90 and it be a B. You scored an 86, an 85, and a 90 on the first 3 tests of the grading period. What possible scores should you earn, or can you earn, on the 4th and final test and earn a B for the 9 weeks? So go ahead and pause it and see what you can come up with. Okay, so the first thing that you should remember is that to find your average, you add up your scores and divide by how many you have altogether. So since we have 3 scores already and we're wanting to know what the 4th score needs to be, I went ahead and set it up. 86 plus 85 plus 90 plus x, all divided by 4. And then that has to be larger than 86, or it could be 86, and it has to be smaller than or equal to 90. So now I have my big old inequality here that I can solve. So I broke it apart into 2 pieces, and I solved it. And there are my solutions. I added them together, the numbers, and got 261. Then I multiply both sides by 4 to get rid of that 4 in the denominator, then subtracted 261 from both sides. And so we know that our score has to range somewhere between 83 and 99 inclusively. Okay, so a veterinarian has a scale for weighing dogs and cats that weigh more than 10 pounds but no more than 65. So they weigh more than 10, so we'll just do W for their weight. So they have to weigh more than 10 pounds. So W must be bigger than 10, so that implies 10 is less than W, but no more than 65. So they cannot weigh more than 65. So they have to be less than, or they could be exactly 65. The weights W that can be measured on this scale can be written as 10 is less than W, which is less than or equal to 65, which is exactly what we came up with. It says graph this inequality. So I'm just going to number by 10s, 20, 30, 40, 50, 60, 70. And we know that it's in between here, and it is including 65, so we want all the W's that are smaller than 65 and all the W's that are larger than 10. So it's everything in between, and it didn't ask us to, but we're going to write it in interval notation because we're smart enough to do that. So we've got 10 not included up to 65 inclusively. Okay, sometimes we have what is an or problem. We talked about the ands now, so let's talk about the or. Remember back to the example that I gave you at the beginning. If I tell you that for Christmas you can have an Xbox or a PlayStation, you know you're only getting one. You're not getting both. And this is called a disjunction. And when we graph the solution, it's two different things, two totally different things. There's maybe not an overlap, maybe there is, but we're looking for this is happening or that can happen. So we have more solutions. With an and, it's only these things that happen at the same time. This and this is happening. With or, we can say everything over here is happening or everything over here is happening. So when we graph it, the disjunction is the union of the two inequalities, and only one condition of the inequality has to be met. So that's why there's more solutions. With the and, both conditions have to be met. Okay, so let's look at this. If the inequalities do overlap, 9 times out of 10, they're going to go in opposite directions. But if they do overlap, which does happen sometimes, like on the and problems, then we know that there are infinitely many solutions, and the solution would be all real numbers. So when we're talking about how to set this up, we've got to use the union. We've got to union our two solutions together, and that's what this U stands for, is the union. So as an inequality, we would say x is less than 13 or x is greater than 13. Think about what that looks like on a graph. X is less than 13. That's all of these numbers down here. Or x is greater than 13. So that's all of these numbers up here. So basically the only thing it can't be is 13. So if we want to write that, this arrow shows that we're starting way down here at negative infinity, which we can never include. We come up to 13, and we're not including 13. Then we're going to union that with starting at 13 and going all the way up to positive infinity, which you cannot include. So let's look at some examples here. What compound inequality represents the phrase all real numbers that are less than 0? So numbers that are less than 0 or numbers that are greater than or equal to 5. So let's plot this on the number line. Now with or problems, there were two ways to write it. We could smush them all together as one big inequality. Or well, two inequalities, but all smushed together. But with the or problems, we have to keep the word or in there. So x is less than 0, or x is greater than or equal to 5. So how could I write this using my interval notation? We always read left to right. So looking at where I'm starting here, starting at negative infinity because it's going forever and ever and ever. This arrow tells me it's going forever down in that direction. So I'm not including, but I start at negative infinity. I come up to 0, non-inclusive, not including 0. Then I've got to jump, so I'm going to union that with my other solutions because all of this can happen or all of this over here can happen. So I'm including 5, and then where does my line go? It keeps on going up to positive infinity, not inclusive, can include infinity. So one method of working these is to work each individually. So if I add 1 to both sides to get x is greater than 3, subtract 3 from both sides, x is less than negative 4. So I have x is greater than 3 or x is less than negative 4. So I'm going to start down here at my negative 4. X is less than negative 4 or x is greater than 3. How would I write this in interval notation? Well, I'm starting at negative infinity, coming up to negative 4, not including, union with, not including 3, up to positive infinity. And it is not correct if you don't put them in the correct order. Just like we read a book left to right, you have to read your graph left to right and go in the order of which they are. You can't switch this and say from infinity up to 3. That's not what this says. It says we're starting at 3 and going up to positive infinity. Okay, so what are the solutions? We've got two different problems that we can work out. You can pause the video and try these. Okay, I want to subtract 2 from both sides. I get negative 9. At this point, I want to divide both sides by 3, so I get t is less than or equal, or just less than negative 3. Over here, it's pretty easy. We just divide both sides by negative 4. Something to remember, I divided both sides of my inequality by a negative number, so I've got to flip the inequality symbol, and I've got negative 1/4. Okay, so on the number line, we're starting at negative 1/4. So if I've got negative 1, negative 2, this would be a half, so negative 1/4 would be right here. Not including, we want all the t's greater than negative 1/4. And all the values of t that are less than negative 3. So negative 3, not including all the t's less than. So what are my solutions? Once again, starting at the left, not including negative infinity, up to negative 3, non-inclusive, unioned with negative 1/4, not including, up to positive infinity, not included. Okay, go ahead and try this one. Okay, so this is an interesting one. Look what ends up happening. When I divided both sides by a negative, I had to flip the inequality symbol. So this says x is greater than negative 4, or x is greater than 6. So if I start reading this left to right, we're starting at negative 4, not including, and we're going up to, well, my arrow keeps on going. We go to 6, but we also keep on going through 6. So we can just write it as one simplified thing. Negative 4 goes up to positive infinity, not inclusive. So you don't have to have the or on this problem because it's already this and that is the exact same thing. I shouldn't say it's the same thing, but it's starting at negative 4 and it's going on up on past there. So everything that's greater than 6, I'm already including it when I say greater than negative 4, because everything that's greater than 6 is also greater than negative 4. Okay, so solve this one. Go ahead and pause the video and give it a try. Same type of thing. When I end up looking at it, everything that's less than negative 3 has already been talked about when I say everything less than 3. So we're starting at negative infinity and we go up to negative 3, but then we said everything less than 3, so we just keep right on going up to 3 and we're not including, and that's my solution set. Okay, so that is it for the day. I hope that you understood this. If you have any questions, you can shoot me an email. And I recommend maybe Googling compound inequalities and finding some practice problems online and giving it a try.